Unit 4, Section 1, Relationships between Sides and Angles of Triangles. You can see the visual. We're going to talk about how the angles and the sides are connected. Let's begin with vocabulary. So we have a triangle inequality theorem. It states that the sum, remember sum is the answer to an addition problem, the sum of the lengths of any two sides must be greater than the third side. Okay, so let's look over at the visual. You can see here, this is the triangle inequality theorem, and basically it's saying A plus B is larger than C, A plus C is larger than B, and B plus C is larger than A. The questions for these are fairly simple, but just keeping track of the sides is part of the importance of this activity. And then we have the angle bisector theorem. The angle bisector of a triangle equally divides the opposite side into two segments that are proportional to the other two sides. All right, so let's look at the visual. Here's your bisector, PS. It's bisecting that angle, and it's creating an X and a Y on the other side. They are proportional to A and B. So you set up a proportion, you remember, with an equal sign in the middle, and you set it up so that it is coordinating on the other side. So if this is A, the one that would be next to A would be B, and then we need to go and make sure that the X, which is across from A, is the next one that we list, and then Y. So you're going to have one missing, so you're going to probably create a variable for the missing one when we get to the question. And finally, mid-segment is the line segment joining the midpoint of two sides of a triangle. So we talked about this being the mid-segment. The mid-segment is exactly in the middle. We can use the theorems and knowledge of mid-segments to solve problems with triangles. Let's see what examples we have. Start with example 1. Find the missing length indicated. So we have an angle bisector. We know that that means that 45 over 20 is proportionate to 36 over something. So one way we can do this is to multiply 20 and 36 and then divide that answer by 45. All right, so when I multiply 20 by 36, I get 720. And then I want to divide 720 by 45. So when you divide 720 by 45, you get 16. So that means that this section right here is 16, but they're asking for the combination of the two. Well, then I just need to add 36, and this whole side is 52. Okay, so be careful what they're asking for. You need to pay attention to what they're asking for. Example 3 says, state if the three numbers can be measures of the sides of a triangle. So remember, we stated that two sides added together needed to be greater than the other side. So let's try it. 10 plus 9 is 19. That's definitely greater than 6. 10 plus 6 is 16, which is greater than 9. 9 plus 6 is 15, which is greater than 10. So yes, this is a triangle based on the fact that the two sides added together are larger than the third side. Let's look at another example. All right, so in example 2, you're being asked to solve for x. Very similar to what we did, but a tiny bit different because we have to actually create an equation when we're finished. So first thing we're going to do is realize that this is an angle bisector, which means 20 over 15 is proportionate to 8 over x. All right, so in this case, 8 times 15, we need to do that problem like we did before. And when we multiply 8 times 15, we get 120. All right, so that's 120. And then we're going to divide 120 by 20, which we know will be 6. So this is 6. Okay, so what does that mean? It means that 2x minus 2 is equal to 8 plus 6, which is 14. But now we have a nice little simple two-step equation. We're going to add 2, we're going to get 2x equals 16, which means that x equals 8. So we just solved for x using the angle bisector theorem. And finally, let's look at example 4. Two sides of a triangle have the following measures. Find the range of possible measures for the third side. So 12 plus 8 is 20. That means that it has to be larger than 20. And what can it not be smaller than? Let's see. If you add something to 8, it has to be larger than 12. So you can't add anything less than 4. Well, really, you have to add something greater than 4. So it needs to be greater than 20 and So basically this third side needs to be greater than 20 because we know that when we add 12 and 8, then the third side needs to be larger than that sum. So what to watch out for? Make sure that you label carefully, watch very carefully the sides that you're talking about when you're setting up your proportion. Make sure that you set them up across from each other, the sides that are proportionate, corresponding. It's easy to mix up things like angles and sides, so be careful when you're doing it. And use those theorems. All right, here's an exit ticket for you to try with some problems. Good luck.